Thank you for joining us live on FK Academy channel. We are going to solve this grade 12 mathematics, polynomials, solving cubic equations. So let's solve by starting with the very first one. Let us begin by rewriting this cubic equation in standard form by subtracting 25x from both sides of the equation. We now let p of x to be equal to this cubic function. Now we try factorizing using the factor theorem. So we look for factors of -50, which are -1, +1, -2, +2, -5, +5. So let's try -1 and see. Then we simplify. After substituting x equal -1, we can simplify now. So this will give us -26 plus 2, which is -24. Hence, x plus 1 is not a factor of the polynomial p of x. So we can try p of -2 and c. And this will simplify to -8 plus 8 plus 25 times 2, which is 50. So plus 50 minus 50. And this will give us 0. Therefore, x plus 2 is a factor of this polynomial. So we can factor the polynomial. In fact, we can factor by inspection. You realize that x squared is common to both this first term here, these first two terms. We can also see that -25 is common to the second term. And by inspection, we factor to obtain x squared. And we are left with x plus 2. Then we have -25. Then we have x plus 2. So we can factor further to obtain x squared minus 25 into bracket x plus 2. So this will give us, by difference of 2 squared, we have x squared minus 5 squared. And this will further give us x minus 5, x plus 5, x plus 2. So when we equate this to 0, we obtain x minus 5 equals 0, x plus 5 equals 0, x plus 2 equals 0. Hence the solutions are x equal 5, -5, -2. So these are the solutions to the cubic equation, which is the first one. Let's rewrite this one too in a standard form. So we have minus p cubed plus 19p is equal to minus 30 is equal to 0. We can choose to multiply through by -1. So we try the factors of 30. So when we let f of x or f of p to be equal to p cubed minus 19p plus 30. Then we can try f of 1, and that will give us 1 cubed minus 19 times 1 plus 30. And this will simplify to 1 minus 19 plus 30, which is, we have negative 18 plus 30, which is 12. So it means p minus 1 is not a factor of the polynomial f of p. Now let's try another one. Let's try 2. So p of 2 will be equal to, we have, it's not p of 2, it's f of 2. So f of 2 will be equal to 2 cubed minus 19 into bracket 2 minus 30 plus 30. So this will give us 8 minus 38 plus 30. And that will give us negative 30 plus 30, which is equal to 0. It tells us that p minus 2 is a factor of the polynomial p cubed minus 19p plus 30. Since p minus 2 is a factor, we can use it to divide the polynomial f of p, which is p cubed plus 0p squared minus 19p plus 30. So we divide p cubed by p, that will give us p squared. We multiply it by p minus 2 to get p cubed minus 2p squared. We subtract now, we obtain 2p squared minus 19p. We drop the 19p here. Then again, we divide 2p squared by 2p, and that gives us plus 2p. And then we multiply 2p by p minus 2. That will give us 2p squared minus 4p. Let's subtract. So when we subtract, we obtain minus 15p here, negative 15p. Then we drop the 30. Now we divide negative 15p by p to get negative 15. When we multiply, you get negative 15p plus 30. When we subtract, we get 0. So the remainder is 0. So it tells you that the quotient is p squared plus 2p minus 15, p squared plus 2p minus 15. So the polynomial factors like this: p cubed minus 19p plus 30 is equal to p minus 2. Then we have p squared plus 2p minus 15. So we can factor the quadratic factor further. Factors of negative 15 that when we add we get 2 are 3, negative 3 and positive 5. Negative 3 and positive 5. So these factors as p minus 2. Then we have p minus 3. Then we have p plus 5. So the solution will be p minus 2, either p minus 2 equals 0 by the zero product principle, or p minus 3 equals 0, or p plus 5 equals 0. So this gives us p to be equal to the c. We need to first of all expand this to get y cubed using the distributive property. We expand to get y cubed plus 2y squared, 19y plus 20. So after doing that, we can rewrite to obtain y cubed plus 2y squared minus 19y. Then we have minus 20 is equal to 0. So once again, we use the factor theorem to check the factors. So let h of y be equal to the cubic equation y cubed plus 2y squared minus 19y minus 20. So we check for h of negative 1. With the third cubic equation, we must first of all expand using the distributive property. We have y cubed plus 2y squared is equal to 19y plus 20. So we rewrite to obtain y cubed plus 2y squared minus 19y minus 20 equals 0. We let h of y be equal to the cubic equation. Then we can now use the factor theorem to find the factors. So using the factor theorem, let's start from negative 1, which is a factor of negative 20. So h of negative 1 will be equal to negative 1 cubed plus 2, negative 1 squared minus 19 times negative 1 minus 20. So this will simplify to negative 1 plus 2. Then we have positive 19 minus 20. 2 minus 1 will give us 1 plus 19 is 20. 20 minus 20 is 0. So it tells us that y plus 1 is a factor of this polynomial here. So we've seen that y plus 1 is a factor of this polynomial here. So to get the other factors, let's quickly perform some synthetic division. So let's write out the coefficients. So we have 1, we have 2, we have negative 19, we have negative 20. So we divide by negative 1. So let's perform the synthetic division. So we add 1 to nothing here to get 1. Now we multiply negative 1 by 1 to get negative 1. Then we add 2 and negative 1. That will give us positive 1. Multiply -1 by -1, we get -1. We add -19 and -1, that gives us -20. We multiply -1 by -20, that gives us 20. We add -20 to 20, that gives us 0. So it means the quotients have this coefficient 1, 1, -20. The given polynomial will factor like this: y plus 1. Then we have y squared plus y minus 20, because we had the quotient of the polynomial to be 1, 1, -20. So we can factor this quadratic polynomial here by looking for factors of -20 that will add up to 1. And these factors are -4 and +5. So it becomes y plus 1. Then the quadratic factor here becomes two linear factors, y minus 4 and y plus 5. So when we equate this to 0, y plus 1, y minus 4, y plus 5 equals 0. By the zero product principle, we have y plus 1 equals 0, or y minus 4 equals 0, or y plus 5 equals 0. And that gives us y to be equal to -1, -5, or 4. So thank you for joining us in this live discussion. See you in another video. Please don't forget to share this video. Thank you. Thank you for joining us live on